G'day guys, Will here. Welcome back to the channel and welcome back to our video series on building the ultimate sim racing and gaming PC. So it's been about a week and a half now since I finished putting all this together. I've had a good opportunity to get it all up and running, do some overclocking of both the GPU and the CPU, get everything set up exactly how I want, test it out with a few games and streams. You've actually would have seen the last couple of videos I did for my streaming and recording were all done using this in the twin PC setup. We even did the little video tour as well where I showed you how I have all that stuff set up. But what I haven't done yet is shown you exactly how I ended up overclocking this, what the settings were, and also some benchmarking as well. So I thought this would be a good opportunity to show you all of that stuff. A lot of you guys have been asking me about it, so here we are. So what I'll do first is I'll take you through the BIOS, show you all the settings that I've got there. I'll also give you a little bit of an explanation of what all the settings do there, but I only want to sort of briefly touch on that because I do have a couple of other videos which I'll link above my head as we go that cover all of that in a lot more detail. So we talk about all the different settings, exactly what they do, and how to overclock your own 9900K or your Z390 motherboard. So don't need to go into a whole lot of detail there, but we'll skim over it again today just so you have an understanding of what my settings are, why I've chosen them, and yeah, then we'll get stuck into some benchmarks and tests. So let's start off with the BIOS here. So what we ended up doing is running a overclock of 5.1 gigahertz with no AVX offset whatsoever. So you can see here my XMP profile is set to XMP1, which is the RAM's default XMP profile for extreme memory performance. You can see here there's an option for XMP2 as well. That's like an ASUS even more aggressive timing overclock there. And I did find that that was a little bit unstable, so I ended up going with XMP1 here. You can see here my RAM is DDR4 3200 megahertz at CAS 16, 18, 18, 38. Now B clock, I didn't end up overclocking here at all. I don't really like overclocking using the B clock for a system like this where, you know, stability is the most important thing, because I do find that that can introduce a little bit of instability, and the performance gains to be had there are generally pretty minuscule. You might notice it in benchmarking and things like that, but for actual gaming performance, which is what this PC is dedicated to, really doesn't make a discernible difference. So we left that at the stock of 100 megahertz. We've got our Asus multi-core enhancement set to enabled and remove all limits, and that gives us full control of everything. SVID behavior I left set to automatic, and again the reasons for that I've explained in previous videos. Now we don't have an AVX instruction offset at all, and I was really happy that I was able to achieve this. Now a lot of games don't use AVX instructions, but a lot of benchmarking and things like that do these days. So the aim generally here is a AVX offset allows you to run a higher clock frequency for non-AVX instructions, and then when the CPU gets hammered with AVX instructions, the clock frequency comes down by the offset. So for example, if we're running 5 gigahertz as our clock frequency, if we set an AVX offset of 1, that would mean that the clock frequency would drop down to 4.9 gigahertz on all cores when we introduce an AVX load. So with an offset of 0 means we're sitting at our clock frequency of 5.1 gigahertz all the time in this particular example. You can see here we've got all cores synchronized here. We want to run all of our cores at the maximum frequency, and we managed to achieve 5.1 gigahertz at a very healthy voltage, which I'll show you in just a moment. Now I was able to reach 5.2 gigahertz with relative ease, but it needed quite a bit more voltage, and I'll cover that in just a moment. And I wasn't really comfortable, given that this is running high loads most of its life, you know, in gaming scenarios and things like that. I didn't really see the benefit of running 5.2 gigahertz and, you know, having all the additional temperature and voltage that was required to achieve that. So we ended up settling at a healthy 5.1 gigahertz there. DDR RAM frequency, you can see there again, it's set to 3200 megahertz, which is stipulated by the XMP profile. Extreme tweaking is enabled. SVID support I've disabled. It doesn't really matter for this purpose whether we have that enabled or disabled. All that basically does is just allow the motherboard to pass the CPU information through to the operating system. I generally leave that disabled because I figure the less communication that's going on, the less chance there is of errors. But again, it doesn't really affect the final overclocking result. So DRAM timing control is just all the default XMP profile. As you can see there, it's all set to automatic, which is the timings of 16, 18, 18, 38. Didn't really feel the need to do any specific RAM overclocking because, again, for the purpose of this machine, you know, we're not racing, well, we are racing, but we're not racing in benchmarks and things like that. We're not, you know, trying to get world records or anything like that. So there wasn't any need to really go into that that just yet. Might dive into that at a later date and see exactly what we can achieve, but didn't really feel the need for now. We'll go down to our voltages now, and then we'll jump back up to our power control and CPU power management and things like that. So you can see here we've got our core ratio limit set to its maximum. That's to make sure that everything's completely unlocked and we don't run into any bottlenecks there. Now our CPU graphics current limit, we're not actually using the iGPU on the CPU, so I just left that set to automatic. Our minimum and maximum ratios I was able to set to 47. Generally you want to have this at around sort of 300 megahertz of your final clock frequency. So at 5.1 gigahertz, you'd want to run this at say 48 or 47. I found 48 started to get a little bit unstable. I was getting a little bit of glitching in games and stuff like that. So I left that at 47. Our maximum CPU graphics ratio, again, not relevant because we're not using the iGPU. So down to B clock aware adaptive voltage. I don't like using adaptive voltage. Now I've talked about that in previous videos. I know that there's a lot of debate around this, and I don't really want to go into a whole lot of detail again in this video because I've talked about it before, but you know, remembering again that this is a gaming machine, we want the CPU to be running at its maximum all the time. We don't want it to be scaling and winding back performance, particularly because that can introduce a lot of frame skips and stuttering. A lot of games aren't particularly well optimized for, you know, multi-core enhancement and, you know, speed shift and things like that. So what happens is when the CPU isn't loaded at 100%, which is often the case in a lot of games, you'll often see your CPU usage can hover sort of between about 20 to sort of 70% depending on the game. What will happen is the motherboard or the CPU will detect that it's not being utilized at 100% load and actually bring down the clock frequency. And we don't want that to happen. We want it to be running at its maximum possible speed all the time because that minimizes the risk of having things like frame skips and things like that happening. So we're running completely manual mode here, no adaptive voltage whatsoever, and no adaptive frequency or anything like that. And I'll show you the settings for that in a moment as well. So our manual voltage is set to 1.31 volts, which is our idle voltage. We ended up setting our load line calibration to level 7, and I'll explain that in a little bit more detail soon. Basically what that means is that under 100% CPU load, we do see a voltage droop down to around about 1.27 or 1.28 volts. So we're effectively running at 1.28 volts at 5.1 gigahertz under 100% load, which I'm really happy with. Really don't see the need to delid this processor either because I'm sort of able to achieve temperatures around the sort of 59 to 65 range when I'm gaming. Under benchmarking conditions, it's getting up to sort of 75 degrees, which is still well within the safe threshold. Usually like to keep my temperatures under about 85 degrees. Anything over that, and I start to sort of want to adjust things a little bit or look at delidding. So really happy with that result. Running our DRAM voltage at the XMP Profiles default of 1.35 volts as well. And I was also really happy with what I was able to achieve with my VCC-IO and VCC-SA voltages as well. Both of those are set to 1.1 volts, which I was really happy with. Often a lot of times you end up having to push this up towards sort of 1.2, 1.3. So just so you understand this on a really basic level, and again, I did go into a lot more detail on this on my Z390 overclocking guide and my 9900K overclocking guide, but basically VCC-IO helps a little bit with your RAM overclocking. So if you're trying to push for really high overclocks on your RAM, or you're running, you know, 4000 megahertz RAM or something like that, generally speaking, you might need to increase your VCC-IO voltage a little bit. You can generally go up to about 1.25, 1.3 before you start pushing the limits. Anything over about 1.3 and you're starting to get into crazy territory. VCC-SA or system agent voltage is the voltage of the B clock as well as the various other components of the motherboard. So it's the voltage that's fed to the other buses basically. But we won't go into any more detail on that. Everything else from here down is all just completely set to automatic. Now we will just quickly jump back up to our external power control again quickly. I just wanted to show you the settings here. So as I mentioned before, load line calibration we set to level 7. Level 8, we were finding that there was, it was actually bumping the voltage up slightly under load. Now this can be a bit of a balance and it does vary between motherboards. Basically basically the VRMs have slightly different efficiency ranges a lot of the time. And what you'll find is that certain V-core voltages, sometimes you might find under load line calibration level 7, the voltage might actually go up slightly under load or drop slightly under load. Effectively, what we want to try and achieve here is a little bit of V-droop. Now, the reason why we want to try and keep a little bit of V-droop there as much as is possible and stable is because under transient loads, you do actually get quite a nasty voltage spike. And you can't actually see it when you have a look at your CPU voltage on the on your software, or even with a multimeter. A lot of the time the sample rate of a multimeter isn't quick enough to see it. It's a really short duration spike, but that can actually be dangerous for the CPU. You can see voltage spikes that go up to sort of 1.4, maybe even 1.5 volts at times. So you want to have a little bit of V-droop there just to sort of protect yourself from those spikes. But again, check out actually Hardcore Overclocking's video linked below, where he explained that in a lot of detail, much better than I could do. Going through the rest here, we've got our AC/DC load line calibration disabled here. We've got all of our current capabilities set to their maximum, so 140 for the CPU. Now, I noticed that when I updated the BIOS here, that went from 170, I think it was previously, down to 140. Shouldn't really matter, but yeah, the previous BIOS version, we were able to crank that up to 170. So yeah, I don't think that's ever going to be a bottleneck, but shouldn't matter. Automatic and automatic for our VRM switching frequencies. We're not really pushing into the territory where we're really stressing the VRMs massively, so we're able to keep those set to automatic, and that keeps our VRM temperatures under control as well. You can set those to manual and then extreme mode if you're finding that you have a little bit of instability, but for me, at this relatively mild overclock of 5.1 gigahertz with basic non-phase change cooling, where we're able to achieve the clock frequencies that we wanted without tweaking that. So that's all fine. Our CPU power duty control is being controlled by T-probe or temperature probe, basically meaning that if our VRM or motherboard temperatures start to get too high, it will bring things under control for us, so we're not pushing things to their absolute ragged edge. Now, everything else from here down is all set to automatic. Again, didn't really need to tweak anything here because we were perfectly stable with the mild overclock of 5.1 gigahertz. So we'll jump back again, go down to our CPU power management, because this is where I've configured speed step to be turned off, turbo mode to be turned on. We've also set the maximums here for our long duration package limit and our time windows, and also our short duration package limit as well. Basically, what that means is that it won't bring the clock frequency and the voltage down when you're under a high level load for a long period of time. So those are all set to their maximum, so we're not having any limitations there. So jumping across to advanced and CPU configuration now, we scroll down to the bottom and CPU power management control. Now you can see here I've also got speed step disabled, I've got my speed shifting technology disabled, and I also have C states disabled as well. So the CPU never goes into sleep mode, it never brings down the clock frequencies. It's basically locked at our maximum clock frequency and our manual voltage at all times, regardless of what commands are issued by the operating system. Now you may find that you need to still set your Windows power management profile to high performance and lock it there at all times to avoid that. But for me, it doesn't seem to be a problem with these settings. It just depends on how the UEFI BIOS communicates with the operating system. It can vary between different motherboards. So again, we won't go into too much detail there now. Now, just quickly touch on my fan and water pump configuration here as well. I did do another video, which I'll link above my head for you now, where I explained how to set all this up as efficiently as possible. One mistake that I see a lot of people make is having their fan speeds run relative to immediate CPU load. So as soon as the CPU load goes up, all their fans go absolutely crazy. Now, because we've got high capacity radiators here and our cooling capacity is a lot greater than what the heat being generated by the system is, we don't need to worry about that too much. Now, unfortunately, I don't have a water temperature sensor installed on the machine at the moment. The motherboard didn't come with one, and I wasn't able to get one here in time to complete the build. Normally, as I mentioned in that other video, I like to control my fan speeds based off my water temperature, because that's really what it's there to control. But what I have done is I've made it off the CPU temperature, but I've added a hysteresis value there as well. So let's just have a quick look at that. So we jump into Q fan configuration, and we go down to here. So you can see CPU fan control. So this is the header that's being used to control all of the fans, so all 6 radiator fans. And you can see here I've got my CPU fan step up and step down set to 25 seconds. So basically what that means is that we need to have a sustained value over or under the threshold for 25 seconds before it will jump up, and it will slowly sort of taper up and taper down. So it's what we call hysteresis there. So we've got our fan lower limit set to 600 RPM, so the fans spin right down. You can hear right now it's very very quiet. And it doesn't ramp up until we get up to quite high temperature. So we've got our upper temperature set to 70 degrees. So effectively, if the CPU gets above 70 degrees, the fans will start to ramp up. And then our maximum duty cycle here is 100%. So that means that the fans will be running at 100% of their maximum speed. Middle temperature is 50 degrees and the fan duty cycle there is 50%. So basically, if the CPU is at 50 degrees, the fans will be running at their 50% duty cycle or half speed. And then if the CPU is at 30 degrees or lower, the fans are running at 26% of their duty cycle or 26% of their maximum speed. And that is sort of the lower limit that I was able to get away with these fans running my fan controller. Anything lower than that and they started to stall and make horrible PWM sounds and things like that. So I left it at that. But as you can hear, it's really nice and quiet. Now, as I said, ideally I would normally have this controlled off my water temperature, not the CPU, but until that temperature probe arrives, I'm kind of limited. I could control it off the motherboard temperature, but because it's an open air case, kind of thought that probably wouldn't work quite so well. So we left it on CPU for now. Now we'll just have a quick look at our water pump settings here as well. Again, controlled by the CPU. We've got our upper temperature at 70 degrees for a 100% duty cycle, 50 degrees for a 60% duty cycle, and 30 degrees for a 30% duty cycle. Now, one thing that I do just want to quickly mention here is that the GPU, in this case, the 2080 Ti, actually generates a lot more heat than the CPU does. And you'll see that later on when we're doing some benchmarking. Generally speaking, if I'm running the CPU at 100% load, the water temperature only sort of reaches about 30 degrees. Whereas if the GPU is running at 100%, we see temperatures on the water around sort of 32, 33, sometimes even 34 degrees, depending on what the ambient temperature is. So that's another reason why it's important to have those fans running off the water temperature wherever possible. But anyway, that is all of the BIOS settings that I think we need to go through. Everything else is pretty much default. So let's jump into Windows now and do some benchmarking. All right, so we'll start off here by having a look at our CPU ID profile so we can see exactly what's going on with our voltages and everything. Now, I am running the trial version of Ada Extreme on this machine because it's not something that I plan to run very often. I do have the fully licensed version on my other machine that I did a bunch of overclocking on, but what we want to do here is just keep an eye on our temperatures. So we'll switch it on for all of our cores. I was doing some monitoring on my GPU previously, which is the reason why that it's not set to all the cores. So we'll have a look here. And we don't need to worry about the SSD or anything like that, or the VRM for now. So we've got all of our core temperatures here as well as our package temperature, and we won't worry about our motherboard temperature at the moment either. So having a look at the CPU ID here, we can see that our core frequency is set to 5.1 gigahertz and it's not budging, it's just sitting there locked at 5.1, which is what we set in the BIOS. And our voltage there is hovering at around sort of 1.28 to 1.296. I saw it dip down just a moment ago. Now, if we introduce a 100% CPU load on Ada 64, you'll see that voltage will drop down. So we'll bring up our CPU ID again. And there you can see it's gone down to 1.261 volts there. Now, admittedly, the voltage sensors that are on these motherboards aren't the most accurate things in the world. If you're getting to extreme overclocking and things like that, you obviously want to use a multimeter to measure this. But we're well within the safe limits of sort of around 1.35 to 1.4 volts here, so I'm not too concerned about that. But yeah, you can see under 100% load there. Temperatures sitting at around about 65, 71 degrees on our temperature gauge there. Now, obviously, we need to leave it for an extended period of time to see what our maximum temperatures are. We don't see those temperatures immediately because we do have a large body of water in this system. We've got about 1.5 liters, 1.9 liters, I think it was in the end. It does take a little bit longer to reach those maximum temperatures. But what I did was I ran a OCCT test for about 3.5 hours. So I'll just quickly show you the results from that here now so you can see for yourselves. So you can see we ran for 3 hours and 36 minutes, and you can see our maximum temperatures never really went up over that sort of threshold of about 60 degrees for the entire time. Now, OCCT is a bit more of a realistic workload than a lot of other sort of stress tests are, and that's why I like to use it for my real world stability testing. If I run 8064 or something like Prime 95, my temperatures do get a little bit hotter. They sort of get up to around 75, 80 degrees. But running OCCT for 3.5 hours here, you can see we never really saw temperatures over about 60 degrees on the CPU, other than the odd transient spike here and there. And you can see also it's not always the same core that's doing the temperature spikes as well, which is good. That means that we've got a nice even thermal paste application at the solder between the IHS and the die is good as well. If you've got a bad chip, often you'll see one core is always a lot hotter than the others, but that's something that's important to keep an eye on. We can see here that, you know, I think it was core 5 was a little bit warmer than the others, but generally speaking wasn't, you know, it was within a tolerable amount, and there was no massive spikes, you know, up to 100 degrees or anything crazy like that. Never hit a thermal limit or anything like that, so everything was fine there. So I'm at this point happy to call that absolutely rock solid stable. As I mentioned, at 5.2 gigahertz, was able to get it stable, but we were seeing temperatures sort of more up to towards 75, 80 degrees. We were having to run about 1.32 volts with V-Droop. So BIOS voltage was set to about 1.38 volts. I'm just not comfortable running at that high, you know, for extended periods when stability is the key, and the performance gains in the real world for gaming really aren't that massive anyway. So that is what I've kind of boiled it down to in terms of my stable overclock. 5.1 gigahertz at around about 1.26 volts under V-Droop, 1.31 volts under the BIOS settings. So let's now run a couple of benchmarks and show you exactly what we get there. So we'll close this off. Now, one thing that I want to just mention about benchmarks here is this is a very, very clean installation of Windows here. I see a lot of people sort of talking about their, you know, their Cinebench scores or their, you know, 3D Mark scores and things like that. And they're often saying, oh, my scores are lower than everybody else's. And it's like, well, what have you got running in the background? Have you got other stuff that's taking up CPU and RAM and graphics card and stuff like that? This is a very clean Windows installation. Literally all I've got installed is SimHub to run my sim software, the motion platform software as well, the Fanatic drivers for my steering wheel, and yeah, I think that's, I've got Trading Paints running for iRacing. All of those programs are killed at the moment, so they're not running in the background, but I don't have any other software running, nothing that's gonna take up CPU cycles or anything like that. I also disable all of my antivirus before I run a benchmark as well, just to make absolutely sure that nothing is gonna be taking away precious resources from the system. So if you're seeing low scores in your benchmark compared to what you think you should be, that is always a good place to start. Ideally, if I'm doing racing and things like that, if I'm trying to actually compete for high overclocks and high benchmark results, I always have a absolutely clean partition with literally just Windows, the drivers that I need to run the system, and the software that I'm testing, and that is literally it. So if you're competing, I would definitely recommend having a separate partition that you use just for that. But anyway, I'll start off with Cinebench R15, and let's run it up in administrator mode. And let's run it here. You can see I ran it previously, got a score of 1,914. So let's run it again on the CPU. Look at all those cores. It's so much faster than the 8086K and the 8700K were. I think the scores I got there in R15 were around 1600, 1620, I think was my maximum. So this is going to be quite a bit quicker. We'll see if we can crack 2 grand. Oh, we did we? Wow, 2,209. That is quick. I wasn't expecting that. So that just goes to show, last time I ran it, I had my antivirus software and a couple other things running in the background. This time I'm running absolutely completely clean. So 2,209 for our Cinebench R15 score, which is a really nice score, really impressive. Okay, so on to our graphics card overclock now. Now this was a little bit more disappointing in terms of the percentage that we were able to gain over the stock clocks, but remember that we're running a Aorus Extreme overclocked card here. So it's already running 1770 out of the box, which is already a pretty heavy overclock. Now I was hoping that it would be a highly binned chip that would mean that I could really push it, you know, and get a massive gain, but you know, it never really was an expectation. So we were able to end up getting about 1810, which was a 40 megahertz increase over the factory overclocked 1770. And that might seem small, but I was able to push it a little bit harder than that for some games. I was able to get up to about 1840, but for benchmarking and, you know, things like that, I was finding I was getting some artifacts with anything over about 1810. So 1810 seems to be the stable point. Then our memory, again, I was able to get plus 500. I could get up to plus 600, maybe even plus 700 in some titles. But again, I was starting to get some artifacting happening when I pushed any harder than that. So plus 500 ended up being where I landed. Obviously, we've got our power target here set to the maximum. We haven't done any overvolting. From what I understand of these cards, you can't really do much with overvolting without, you know, running aftermarket BIOSes or, you know, unlocked BIOSes and stuff like that. And I really don't want to get into volt modding the card. Again, for the purpose of this build, it's just not necessary. If it was a overclocking and, you know, overclocking racing build or a benchmarking racing build, then I would get into all of that. And I am keen to get back into that kind of stuff again, but not for this particular build. So that is our settings there. What I'll do quickly now is I'll run you through a run of 3D Mark Time Spy. I'm just running the demo at the moment because, again, I'm not really competing with this machine. But we'll run the demo and see what kind of score we get. I actually haven't run this yet, so I'm in the dark as well. We'll see together what we get for the first time. But let's run it. Now, just while it's loading here, we will also mention that we are running at 1080p 30 hertz. That is the limitation of my recording device that I'm using to capture the stream, which is the reason we're running that. But we don't have any frame rate caps in place or anything like that, so I don't believe it will impact the scores. But just to keep that in mind, that is the resolution and rate that we're running for our refresh rate. So anyway, we'll load this up, run it through, and see what we get.
No resistance. I give up. No resistance. It's a drift. Out of my control.
Hit the current, made my bed in the whirlpool, spiraling down, trapped in a circle, drowning in front of my eyes like it was virtual. No control, arms flapping as I hurtle into the unknown, tied on the waist, unconsciously sealing my own fate. No resistance or game being played. I chose the life of a castaway. No resistance or game being played. spiraling down, trapped in a circle, drowning in front of my eyes like it was virtual. No control, arms flapping as I hurtle into the unknown, tied on the weights, unconsciously sealing my own fate. No resistance or game being played. I chose the life of a castaway. I chose the life of a castaway. Trapped in a circle. No resistance or game being played. No resistance. Hit the current, made my bed in the whirlpool, spiraling down, trapped in a circle, drowning in front of my eyes like it was virtual. No control, arms flapping as I hurtle into the unknown, tied on the weights, unconsciously sealing my own fate. No resistance.
All right, let's see what we got. 15,382. So I actually don't know if that's a good score or not. It's been that long since I've run this on any machine that I can't remember what's a good score. So let's go online and compare here. So, okay, better than 98% of all results. that's pretty good. So having a bit more of a granular look at the results here, we've got one that is in the 18,000 range, one that is in the 20,000 range, and I'm assuming that must be liquid nitrogen cooled or something like that. The majority of people are sitting well below us though. So that is pretty cool. Just have a quick look here at the individual scores as well. So 15,382 3D Mark, 16,113 for graphics, 12237 for CPU, and 102.65 frames per second there. And yes, so that is pretty much it, guys. Now I can tell you also that the maximum GPU temperature, I wasn't recording for that particular test because obviously I didn't want to have anything running in the background that would take away from the system resources. But the maximum GPU temperature that I'm seeing is around about 55, 56 when the water temperature gets up around 33 degrees. And that's still without the fans running at maximum as well. So definitely well within the tolerances. But guys, that is pretty much it. So yeah, hopefully you found it interesting. I know a lot of you were wondering about the final results that we got from the system. So there you have it. So if you are interested in picking up any of the gear that's gone into the build of this PC, you can use the affiliate links in the description below to do that. Small percentage of the profits from those sales go back towards helping out the channel, which is what's made this possible in the first place. So I really do appreciate your support there. If you want to see any more details on the build, the assembly, how we put it all together, how we bent the lines and all that stuff, there is a video guide that I put together over the last couple of weeks. Link to that playlist is above my head for you right now. But yeah, guys, above all, thank you very much for watching, and make sure you hit the like button if you've enjoyed it, hit the subscribe and the notification bell as well so you don't miss the next one. And yeah, I'll see you guys again soon. Bye.